I haven't done any prospecting there.
Right?
Okay, so do we have the next presenter here? That's Madhu, I think. Yeah, Madhu Thangavelu, are you there? Oh, David, hi.
Greetings. I think I'm the presenter today. I've been talking with Madhu, and he said, could I please step in?
Okay, great. You're welcome. No problem. Okay. David Shrunk, then I'll present you instead of Madhu, and I'll just read off from the abstract there. So you're an aerospace engineer and medical doctor. That's a bit of a unusual combination. Not unheard of, but a bit unusual. And have been working a fair bit on nuclear medicine and diagnosis, radiology. And you have also written a book about the moon. So please go ahead.
Yeah, I wrote a book with Madhu and two other people who were experts in the area. So we looked at the future moon and had fun doing it. We looked into every aspect of it. It's a challenge, but I learned a tremendous amount, and we're continuing to push forward in this idea. And the talk today will be a futuristic kind of a superficial but overlook of what might be possible in the next 50 to 100 years with what we have now and what's possible. So I have like 70 slides in 25 minutes, so I'm going to go quickly. Bear with me.
I'll let you at it. I'll mute myself and let you have the floor for 25 minutes. Thank you. Or go ahead.
So are we good?
Yep, and I hear you too. So you're all set.
Our topic is lunar lava tubes and chambers, optimum sites for permanent lunar settlement. Myself and Madhu.
Oh boy, I agree with you. I agree with you thoroughly. How are you doing, Dave?
Oh, doing well. We're scurrying around. My daughter has a big party here for her birthday, starting in about an hour and a half. So,
Dave, I thought I sent you slides last night with the beautiful logo and everything. You didn't see it?
I don't have it downloaded.
Oh, okay. Well, I added the latest news from University of Trento
Yes.
in Italy, and I added some slides at the end of it. So if you can pull up those, unless you've made many changes on this one. Let me see. Are you able to look up your slide of your email?
I could. It would take a little bit.
Oh, well, if you can, then you'll enjoy sharing the slides from University of Trento. I added them just at the bottom so that you can say that's the latest images, if you like that. But you have more than plenty to cover, Dave.
So why don't I buzz through these, and maybe we can add yours at the end.
That sounds like a good idea, David. I think start with yours as you have planned it, and then we can add more at the end.
Well, that's good. I mean, I added those slides for my panel intro, Nicholas.
Yeah. Okay.
Yeah.
Yep.
So, but
yeah, good. Then we can use them there.
Okay.
Thanks. And please proceed with your presentation, David.
Okay. First of all, this is probably the one slide you'll remember from the whole thing. I recently went to Mongolia for another reason, and this is a picture of my wife holding an eagle. It's a young eagle. That's Genghis Khan in the background. This has nothing to do with lavitudes, of course, but probably the one slide you'll
it looks like Genghis Khan's riding the eagle. All right.
So we want to talk about the future planet Moon. This is our next home in space, our second home in space. This will be going to the moon and developing the moon will be our next stage of human advancement. We want to establish permanent human settlements on the moon. The moon is nearby, it orbits the Earth, it has resources and gravity, it's a stepping stone to space. And we have enabling technologies, artificial intelligence, reusable rockets, and so on and so on. And all these technologies are advancing rapidly, so we can count on having this to enable us to accomplish this task. Lunar resources, we have sunlight available all the time, inexhaustible and predictable. The moon has elements that are useful for all the living and construction things that we want to do on the moon. Interesting, the oxygen is 60% of the lunar surface. So whenever we mine or want to have titanium or iron or silicon and we recover those metals, the waste product is oxygen, which is quite useful, obviously. In the South Polar region, we have light elements for resources, and we have water, ice, and the cold traps been extensively researched. This shows the hydroxyl ion concentration is in the pole. That's the right-hand side of the water molecule. It's in the polar regions. The L-Cross mission 15, 20 years ago impacted a crater in the South Polar region, and the plume that was thrown up had all kinds of organic compounds, methane, methanol, ammonia, sulfur compounds, and so on. This is the basis for an organic chemistry industry, very valuable. In terms of topography, there's sunlight availability in the South Polar region for solar power activities. This is from Bucy and Sputus. The red dots show points of maximum illumination. The red arrow in the center shows that two dots close side by side. There's more than 90% of sunlight availability during the lunar year. So there's potential for long time source of power from sunlight. At the top of the slide here, you can see two dots. That's the summit of Malapert Mountain. These high elevations can be used for communication and power beaming links. This is iconic image from the Japanese orbiter. You can see the Earth and the Malapert highlands and the Shackleton, which is the South Pole. So we can consider having Earth-directed robotic mining and processing, storage, and transportation. As in the previous talk, we're going to have robotic activities in the South Polar region. We can have Earth stations that control robotic operations. And from the summit of Malapert, we have line of sight to multiple areas throughout the South Polar region for command and control of robotic devices used for mining and transportation. We can also consider having power beaming between these sites, a direct line of sight. So we can consider having a robotic mining and transportation in the recovering ice and other minerals in the South Polar region. We can do this telerobotically, potentially. For human habitations, there are hazards that are pretty difficult to overcome. We have temperature extremes. This is a plot of the day to night cycle of temperature on the surface of the moon at various latitudes. This is very extreme thermal stress for humans, obviously, and for any kind of equipment we put on the moon. The brown line at the bottom, that's the nighttime temperature when there's no sunlight at all. It drops to 40 degrees Kelvin, which is amazing. We have ionizing radiation. We have cosmic rays, particulate. They're atomic nuclei at very high energy. They're of solar and galactic origin. And we have gamma rays, photon radiation. This radiation is extremely hazardous. It's 2 orders of magnitude above safe levels. So the lunar surface everywhere on the moon is unsafe for human activities. Radiation protection from spacesuits and space cabin, they're both inadequate. They do not stop the radiation. It's not practical to put anything on the surface of the moon that's just a spacesuit or a space cabin. Deleterious effects of radiation include your major organ systems and so on. Lunar dust is a problem. It's ubiquitous on the surface. It's a biological hazard to lungs and skin and eyes, and it's also a hazard for equipment. It's abrasive and reactive. Micrometeorites, these are microscopic, but they reach the lunar surface at high velocities, tens of kilometers per second. Of course, these are hazards for spacesuits and equipment that's operating on the surface. So the surface is not a good place to be. Solution is to go underground. We can shield structures with several meters of regolith. We can excavate the surface and put, say, an inflatable habitat on the surface and cover it with regolith. The only problem with this, at least in the beginning, the covered habitats have a psychological stress because they're isolated. These are psychological stress factors from having an underground cabin that's just barely enough to support life and activities. This was in the Antarctica. This was what was observed. All kinds of stress factors that limited human performance. So forced socialization with crew members, increased, decreased sensory input, and so on. They had a front-end loader for moving snow around, and they could barely operate that. It was their function was quite reduced because of this isolation. So a better underground solution potentially would be the lava tubes or chambers. And this is the one we're talking about. There's 200 lava tube openings in the lunar surface. This is the Grail mission. It looked at gravity gradients on the moon, and the red areas are the areas of high gravity or mountainous areas, and the blue areas are decreased gravity or tunnels, or not tunnels, lava tubes or rills, the collapsed lava tubes. And you can see that these are in the blue areas. This sinusoidal pattern is ubiquitous on the lunar surface. If just a few percent of these blue linear areas are intact lava tubes, you may be looking at the subway map of the future moon, because we can use these to connect one to the other and have an underground network of transportation. This is a map of what we've seen so far, around 200 or perhaps more lava tubes openings in the lunar surface have been detected. You see in the middle there Mare's Hills and Mare Tranquillitatis, which is the subject of the paper that just came out in describing the opening there as a potential lava tube. So there's a lot of evidence here for underground structures. In the Grail report, the authors concluded that there are large volumes underground, that some may be as much as 3 kilometers wide and half a kilometer high, and 60 or more kilometers long, and they have a thick roof of 20 meters or more. So an interesting view here is that this is the map of the moon taken over an 8-year period. The numbers represent a flash of light that was recorded from a meteorite strike on the moon. Something that was large enough to generate light, it was recorded. And it's interesting that the meteorite strikes are on the left and right sides, the east and west sides, but not in the middle region. So fortuitously, the lava tubes we're looking at are right in the middle, where there's no recorded strikes, at least in this 8-year period. So lava tubes are, from what we understand, are fortuitous ideal geologic structures for human settlement. They offer absolute protection from space radiation. The roof is thick enough to stop all the radiation. There's no lunar dust. The space weathering that produces lunar dust on the surface, it does not exist underground, so that problem is virtually eliminated. And the lunar tubes, the chambers have a stable temperature that been variously estimated to be around 60 or 70 degrees Fahrenheit. If that's true, it's ideal. The main thing is that there's no thermal stress from a wide variation in temperature. It's a constant temperature underground. So these lava tubes, based upon what we know, would be potentially able to accommodate large facilities for energy systems, greenhouses, manufacturing. Nuclear reactors are being developed that are reliable and constant, safe, under development. They would have a 10-year lifespan, perhaps more, so we can have a constant source of energy potentially with this technology. Lava tubes would be able to accommodate housing, life support systems, recreation, and storage. And if we project forward optimistically, we can consider the lava tube as a first lunar base. And it would be in the equatorial mid-latitude site facing the Earth continuously. And what I find interesting is that this would enable us to shift our emphasis from gathering scientific data. We continue to do that, obviously, of course, but we shift to development. The next phase, we first explore and then we develop. So the current lunar missions are focused on science return, and they're nation-based, and they are divergent efforts. That is, the various nations go to different sites on the moon and collect data, and that's good, where we're getting a broad example of what the moon has to offer. So ESA, Japan, India, USA, China, Russia all go to different sites, and we're gathering all kinds of interesting information. The lunar base mission would be the development focus would tend to go to one site, and this could be an international effort, and it would be convergent rather than divergent. So this could potentially involve all nations, development of a lunar base at one site, and this would allow corporations to be involved, both profit and nonprofit universities and so on. And so if we selected a base B on the moon, all the various countries could contribute and cooperate to build up this base. It would be a one world effort, which is very attractive. The nations could provide science missions and resupply, and they would provide governance at the lunar base, municipal type of government or a port authority. And corporations would provide energy, housing, transportation, manufacturing, communication. So all the corporations could be involved as well as the nations. The next step will be to have a lava tube exploration strategy. This would be 6 to 9 years or 10 years to find the sites that we like. The one that's recently described at Tranquillitatis would be a very likely site to begin. This could be a human exploration or more or less, or probably robotic, and we would identify the optimum site to begin this project. And this could initiate the first off-world human settlement. This could be I'm wishful thinking perhaps, but this would be a peaceful endeavor involving all nations. It would establish our second home in space. We have the means to get there with heavy lift rockets. This would provide us with all of our machinery. It could provide us with water, maybe liquid nitrogen for an atmosphere. And shows an entrance to the lava tube underground. This is a image that Madhu came up with. Shows scaffolding under the skylight in the underground chamber, and more development activities. So we have the resources in the South Polar region, and this would be a site for a robotic recovery of these resources. How do we get them up to the lava tube in the mid-latitude area? Perhaps we could create a railroad link from the South Pole to the lava tube base, and transport water, organic materials, and ores to the lava tube base. This is from our first book, A Railroad on the Moon. I believe that Northrop Grumman recently received a contract to study lunar railroads in the South Polar region. So it's theoretically possible, with all these factors coming together, that we could have a self-sustaining lunar base achieved in the latter half of this century. All the technology that we need is available. It's just a matter of putting them together. And so a self-sustaining planet Moon would be possible. And the advantage of the Moon is that it would give us access to the unlimited material resources of space. The asteroids that are, or the near-Earth objects that are now a threat to the Earth, could be captured and mined for their resources. And we could build up solar panels on the Moon to eventually provide the Earth with all of its energy needs. Lunar tubes appear to be a very suitable, if not optimum, site for human settlement. The selected site can be developed into an international off-world settlement. The planet Moon would then become our second home in space. We can then replicate this effort. If it's successful, we can do the same thing with Mars, and then open endless frontiers. So that's quickly my talk. About 20 minutes.
You're good on time. Yep. Did you have, or do Madhu have additional slides there, or do we go to question and answers?
No, you don't need additional slides, Nicholas. I think the case is made very nicely in Dave's talk.
Let's see. Do we have any questions there? Marufa has a question. I think it is for you. What is your vision for lunar settlements for the next 20 years? Or was that for the previous speaker? Maybe, I don't know.
Oh, well, Dave, I think you addressed it in the last slide. 2050 to 2070, I think. Slide 78. Very good, achieved in 2050 to 70. I mean, I think, as the good professor said, it's all about the will of a nation or the will of a species, Nicholas, or the person who asked the question. It's not politics, it's not money, it's not anything else. It's the will of the people to want to do something like this, These are large projects, but as we conclude in our book, it has to do with wanting to do it. I mean, that's what happened with Apollo, right?
Sorry to interrupt. This question is for the presenter who just presented for last few minutes. How he envisioned, like, what is your dream for the next 20 years? Like, if you were going to the moon, how do you see yourself? Or for David Shrunk?
The next 20 years, we have a pretty extensive exploration and definition of lava tubes. There are multiple lava tubes. We believe on the moon, but the one that's been described recently at Mare Tranquillitatis and the Marias Hills would be a very attractive sites for exploring lava tubes and defining lava tubes. And I can see a robotic process in the next 5 to 10 years, and after that, I think we could if we can discover or we confirm the lava tubes are there, we can start planning on human missions and just building this process up. The the Starship has such a large capacity, lift capacity, that we can jumpstart this process. Once we have identified a lava tube, we can jumpstart this pretty on a relatively short time period. So I'm the optimist. The advantage of establishing a base on the moon, a human settlement on the moon, is, as I pointed out, we gain access to unlimited resources. We can build solar panels on the moon and launch them from the moon with mass drivers to Earth orbit and supply the Earth with all of its future energy needs with Earth orbiting solar power satellites that were built on the moon. So we would no longer need to have fossil or fission fuel power plants on the Earth. We can begin to reduce the carbon emissions and so on. There's all kinds of things you can do once we have access to space from the moon.
Would you go to the moon if you were selected? Will you go?
Of course.
Yeah, awesome. Thank you.
Yeah.
We also have a question from Chris. He wonders if there is a published list of known suspected lava tube openings. You had a nice picture there, but
sorry, scroll down here. This one?
the previous one, wasn't that of suspicious? Yeah, that's one too, yeah.
And
yeah. That's lava tubes, isn't it? Gravity gradients, yeah.
The best is a logical explanation for the long, sinuous blue structures on the moon. A logical explanation is that these are intact lava tubes, or they are collapsed lava tubes. Like the rills, like the Hadley rill that was one of the Apollo site missions. These, just a few percentage of these are intact lava tubes. So we could go from one tube to the other and tunnel between one and the next and have a transportation network on the moon. We just make it into a very pleasant, livable place for significant populations.
Yeah, a ready-made subway system, yeah. And you got the map there already, that's great. Yeah, and Madhu put up a link as well, so we have a list of lava tube openings. Right. I think that's good. Any other comments or questions there?
I have a question.
Yes, Cengiz?
Yeah. Thanks, David, for the nice presentation and for the very important information. Do you have any study on how to make these lava tubes livable? The first things to do in making them, livable.
Well, the house has been built, and once we go into lava tube, the structure is there. All we have to do is bring in the plumbing and the electrical. That's oversimplifying it, but we could have inflatable structures placed inside the moon, and if we had a nuclear reactor to give us energy, then we could start building up everything. And it would.
So you are thinking that after making a port, for example, then you can do anything inside.
Yes, it's a nice, safe, comfortable place. It's too good. It's constant temperature, no lunar dust, protection from all the hazards of space. We can create living conditions like the underground mall in Toronto. I had a chance to visit there. A large structure, it's all underground, and we would have the same, just build up the same type of structure on the moon.
Okay.
The hazards of space are really significant, and on the lunar surface, actually, when the radiation hits the lunar surface, it causes radiation. It transforms the materials on the surface of the moon into radioactive elements. So going underground is a perfect solution, and these the lava tubes are just very fortuitous that they're there. We take advantage of that, and we can speed up our ideas for space exploration very dramatically by going to the moon. We can use the lunar resources to build, have robotic devices that build more robotic devices using local lunar materials. So we can have a self-sustaining manufacturing process. But all of this has been done on the Earth. We can just replicate it on the moon. So think optimistically, think big.
And I think Dave made the point that we are used to living under a blanket of atmosphere, and we don't really appreciate what a small meteorite can do to you. The airburst that happened over New York City 2 days ago, that asteroid fragment was clocked at 37 miles per second. 37 miles per second. We don't do those kinds of bolides and bullets and stuff like that on planet Earth. We have to somehow come into, recognize what cosmic energies and cosmic velocities are. And we'll do that on the moon. And of course, Dave is a radiologist. He has told me many times, you don't know how the body fails when you're subject to radiation. Dave, you may want to give us a lecture on that the next time.
My idea is to avoid it.
Yeah, that could actually be interesting too. What is it we are wanting to avoid? There is another question from in the chat, and that is, will it be possible to get the sat-nav and geostationary positioning system in the lava tubes, or are they protecting against that too?
Well, we'll have to have the surface structures for communication and so on, if I understand your question.
Here we know where we are because we have
Yeah.
GPS on and sat-nav on the phone, so we can just look at the phone if we get lost. Can you do the same if you're inside the lava tube?
No. You'd
This
have
was
to make a
Dave,
map.
this was a question asked just a few minutes ago in the International Moon Day as well. And
Okay.
there were some miners in the group. And the only way to do that seems to be with the relays, Nicholas. I can't think of, miners used different kinds of communication systems, but they are all very low bit rate systems.
Yeah.
And we can use, I don't know,
So-
lasers, multiple relays all over. Just think it.
Right. So probably not GPS, but some.
Maher, we have communication systems
great.
that are high bandwidth, and we can do underground triangulation, get the equivalent of GPS underground.
How would you do that, Greg? I mean, what do you use? What is the?
We have a system that we patented, and it uses very low frequency radio triangulation that will go through the rock.
Will go through the rock, I see.
Yeah, it'll go through water too.
Yeah, I think I heard you say that at the, was it at the ISDC or somewhere?
Yes.
Yeah, okay.
One more point. Spacesuits on the surface of the moon are very complicated, very expensive, heavy, and so on. When you're in a lava tube, the spacesuit would be much less complicated, much simpler. Just having like a wetsuit on. You don't need protection against the temperature extremes or radiation. So spacesuits in the lava tube would be much easier to use and much less expensive, much less complicated. So
Less bulky and more aesthetic, Dave.
yes.
Great. That was a good concluding remark. And thank you very much, both of you, for this quite interesting forward-looking presentation.